During this section, we are going to be building a TCP chat server using the chat box previously and learning more about Tokyo as we do so. During this video, we are going to be looking at AsyncRead as a class and converting one into a Tokyo type stream. Begin by building a new project called chatserve. And if we open up cargo.toml, we're going to need to import some things. The first is the failure crate, which we introduced at the beginning of the series at 0.1.5. We're going to need to import futures as well, 0.1.25. And we're going to need Tokyo, which is at 0.1.15. These will probably be more up to date when you use them. A TCP connection creates an async read and an async write. Now the async read has a poll method which we can use to grab data, but we can turn this into a future or a stream if we like. One of the problems with TCP is it's kind of hard to know when someone has sent everything they want you to use before you send anything back. You can kind of rely on new lines a bit sometimes, but we're going to want to interpret JSON data. So we'll start by creating a generic struct, a JRead, which will take an R of async read trait. It's actually going to need quite a few things. We had two options here on how we could really handle knowing when we've got something. One is a control character for knowing when we've reached something, but at this point we've really only got bytes, and I didn't want to convert into string directly until I knew I had the right number of bytes, because there's often a problem at the edge if not the right number of bytes have been sent. So what we've gone for instead, or what I'm going for in this project, is the first set of bytes will either be numbers or a colon, and that will tell us how many bytes they are going to send for this usage. And once we've got enough bytes, we'll handle that, send something back to them, and then we can wait for some more bytes again with a number of how many bytes they're going to send at. It's not a perfect system, but it will at least enable this to work. So the first thing we're going to need is a buffer for actually calling async read with. We need to know how long the result was, so we'll store that as a bufflen. And we'll need a pointer to know how far through that buffer we are in our own reading. Now we want to know whether we are reading the length or the value. We're just maintaining our state within this read loop. So are we trying to find out how many bytes we're going to read now, or are we actually reading those bytes? So len is we're trying to read the length, and val is how many bytes we're reading, and we'll read them into a vec. So we have a variable called reading, and this stores an rding. And finally, we will have our actual async read, which we will call r. This has quite a few variables, so it's worth creating the new function for it. No, there's nothing terribly complicated about that. Now we're going to implement stream for our JRead. The item type of this will be a string, because we're going to return a list of strings which are complete send items, and the error type will be a failure crate type error. So we'll need to import that. Finally, our poll function, which takes unmute self and returns a result of async of option of self item, which is string. And if it's not returning the async, then of course it's returning self error. So for now, let's just quickly throw an answer. OK, sum hello dot to string. That should actually be OK async sum hello dot to string. So now it compiles, but it doesn't really do anything. So the first thing we're going to need to do is to loop, and this will just keep looping. Anytime it gets not ready, it needs to make sure its state is correct and return not ready. But anytime it gets something that is ready, it can just keep moving between its modes and trying to return items. If self.pointer is equal to self.bufflen, that means if our pointer has reached the end of the buffer, then we're going to need to load more data. Otherwise, we already have enough data, so there's no point in doing this. So we'll set self.bufflen to the async read value. But the async read, of course, could return a non-value or not ready or anything like that. So we're going to need to check its poll read method. So of course it takes unmute self.buff to read it into. So if we've got an error, that's going to return the error. as the question mark will handle that. But otherwise, we need to have an async ready of n, in which case we can pass n to the buffer. If we get a not ready, then we're going to need to return OK not ready. Of course, we need to do the poll read on self.r, our actual reader. And at which point we've done this, we need to set our pointer back to 0. So our buffer is now set to having enough data in it. But we can do better than this. I mean, that match sounds like it takes quite a while, but there's actually a macro included in the futures crate called try_ready, which handles the not ready case for us and the error case. So we can get rid of that question mark and get rid of everything on the other side of the match. And this does exactly the same as what we put in our match statement once we've imported it. So let's use futures try_ready. It's a lot like the question mark operator, but for handling futures. Second, if our buff length is 0, then that means we have not actually got anything in our buffer, and we can say we are finished. And this stream can now return OK ready of none. And that is the closing of the stream so that everybody knows we are done. There's no more data. The connection is closed. Or whatever our stream is sourced from, whatever our async reader is, that's now closed. So now we're going to do a match on the reading state. So either we're reading its length or we're actually reading data. Let's assume first we are reading the len. At the start of this, the len is 0. Now we'll take this as a ref mute value so we can tweak it as we wish, as we read. And we're just going to read a byte at a time from the buffer. So here we're going to match on self.buff at self.pointer. All right. And if we're reading length, we should either be getting a colon or a digit. So if we get a colon, and I've marked that as a B for byte, because we are comparing on a byte array, in which case we are now going to change from reading length mode to reading text mode. So self.reading now becomes rding colon, and we're reading a value, the string value that we're aiming for. The length we're aiming for is MB, and the vector we're going to build is just an empty vector. If we have any other value that is from 0 to 9, so we'll do v if v is greater than or equal to the 0 byte, and it is also less than or equal to the 9 byte. Then we're going to increment our reading value here. The value of MB can now be multiplied by 10, and then we'll add the digit on the end. The value at MB times by 10 plus, and we'll take whatever V is, and that should be a number between 48 and 58, maybe 57. Anyway, we can take away 48 from it to get its actual numerical value. The ASCII value of the 0 character is 48, so we take that away and we convert it to a U size so we can add it. There is of course one more case that needs handling, both for the rding len and both for self.reading and rding len. So in the case we have a value we're working with, I'll come back to this in a second. I'd just like to get rid of the red arrows. So any other case, I'm just going to ignore. Up to you how you handle that. Feel free to change that for your own project. But that is helpful having that ignored for handling new lines and carriage returns, etc. So we're reading the value of this, and it needs to be ref mute to actually read it. N is copy type, so we don't need to worry too much about that. So here we're going to let pdist equal the minimum of our current pointer plus n, the total value required, minus the length of our vector that we've already put together. So pointer plus n is the final result, right? Versus the length of the actual buffer. We can't go longer than the buffer, so we're going to limit pdist on the length of the current buffer. At this point, we're going to append to our vec that's storing all of these bytes, all of the bytes between our current pointer and pdist. We're going to convert that to a vec, so it's going to make a copy of it so that it can append it to the other vec. It feels like not perfectly efficient there, but it will work. And then we're going to set our current pointer to the new position of pdist. If vlen equals n, that is, if the length of our vector is the length of the result we wanted, perfect, we can return that result. But before we return that result, we had better set our state into a ready state for the next read. So let res equals string from UTF-8, and that is v.clone, it should be. Again, another copy, but that's because it's part of a borrowed mutable. And before we return that res, self.reading equals, and then we're going to set it to a len at 0. So it's ready to read again. And here we can return async ready with an actual value, so that's sum and res. During the recording of the video part of this, I did forget to increment the pointer on this, but that does get fixed a video or two later. So yeah, correct that to v.clone. And of course, we never reached this statement, so we can get rid of that safely, because that was in a loop. These things are never used, but they will be used later in the project. So this is complete, but it's kind of awkward to test as things are. We could write tests, but I'm going to instead lead into the next part where we build the writing side of this, and then in the video after that, we will start bringing these things together.